When establishing a service entrance ground and subsequently grounding a separately derived system such as the transformer downstream, it is indeed advisable to bond the second ground to the service entrance ground system. This practice creates a redundant pathway for fault current, which is crucial for ensuring that all grounded systems maintain the same electrical potential. For bonding the second ground to the service entrance ground, use a grounding electrode conductor, or GEC, sized as a main bonding jumper. Now let's turn our attention to the tap rules outlined in section 250.122d. The unlimited length tap rule doesn't explicitly state a ratio between the tap and the conductor being tapped. However, there are generally accepted guidelines that should be followed. Firstly, for taps that are less than 100 feet in length, the tap conductor should be sized to be no less than 1/3 the ampacity of the conductor being tapped. Secondly, for taps that extend 100 feet or more, the tap conductor should be sized to be no less than 1/2 the ampacity of the conductor being tapped. These guidelines help ensure that the tap conductors are adequately sized to handle the potential fault current and prevent overheating or other electrical hazards. Considering a situation where a 2000 amps feeder is tapped with a 15 amp circuit, it's important to analyze whether this configuration adheres to established guidelines. In this specific instance, the ampacity of the tap, which is 15 amps, is approximately 1/133 of the ampacity of the feeder, which is 2000 amps. This ratio falls within the recommended 1/3 ratio for taps that are less than 100 feet in length. Therefore, based on this analysis, the tap in question would not be deemed unreasonable, as it complies with the established guidelines for tap conductor sizing. However, it's crucial to consider any additional factors that may influence the determination of whether the tap is appropriate for the intended application. Thusly, the load requirements of the equipment being supplied by the 15 amp circuit should be carefully assessed to ensure that the tap conductor is adequately sized to handle the anticipated current draw. Secondly, the length of the tap conductor should be taken into account, as longer tap conductors may require larger conductor sizes to compensate for voltage drop. Thirdly, the ambient temperature and other environmental conditions should be considered, as these factors can affect the ampacity of the tap conductor. Fourthly, any applicable local codes or regulations should be consulted to ensure compliance with all relevant requirements. By carefully considering these factors and adhering to established guidelines, it's possible to determine whether a tap is appropriate for the intended application and ensure that it meets all safety and performance requirements. In summary, when grounding separately derived systems, ensure the secondary ground is bonded to the service entrance ground using a grounding electrode conductor, GEC, sized as a main bonding jumper. For unlimited length taps, while there's no specified ratio in section 250.122d, aim for a tap conductor size of at least 1/3 the ampacity of the tap conductor for taps less than 100 feet and 1/2 the ampacity for taps 100 feet or greater. Always consider the specific load requirements, conductor length, environmental conditions, and local codes to ensure a safe and compliant electrical installation. This approach helps maintain electrical safety and ensures that the system operates efficiently and reliably.